NMR spectroscopy. State the two types of nuclear magnetic resonance spectroscopy. The two types of nuclear magnetic resonance spectroscopy. 13. CNMR, information about how carbon in a molecule is arranged. 1H NMR, how hydrogen in a molecule is arranged. 30. CNMR, information about how carbon in a molecule is arranged. 1H NMR, how hydrogen in a molecule is arranged. Key fact about atomic nucleus: odd number of nucleons in nucleus, and when does magnetic fields cancel out? They have a nuclear spin, and therefore they have a weak magnetic field if they have an odd number of nucleons in the nucleus. And magnetic fields cancel out when nuclei is spinning in random directions. Two things that happen when a strong external magnetic field applied to nuclei, and what are hydrogen nuclei and what does it have? One strong external magnetic field applied to nuclei, the nuclei will align with it or against it, and the nuclei aligned with the external field has slightly lower energy than opposed nuclei. Hydrogen nuclei, the single protons, so they have a spin. What radio waves of right frequency give the nuclei, and what radio waves of unright frequency give the nuclei? Radio waves at a right frequency give the nuclei that are aligned with the external magnetic field enough energy to flip to higher energy level, and then the other one, nuclei opposed to external magnetic field, emit radio waves and flip down to lower energy level. Where are there more nuclei aligned? There's more nuclei aligned with external field, so the overall absorption of energy. What will affect amount of electron shielding, and how is nucleus shielded? Any groups of atoms around the nucleus is partly shielded from effects of external magnetic fields by surrounding electrons. What will nuclei in different environment feel? In different magnetic fields, so they absorb different amounts of energies at a different frequency. What does the atom environment depend on? It depends on all the groups that's connected to right along a molecule, and a requirement to be in the same environment, the two atoms must be bonded to the same thing. Chemical shift, the differences relative to a standard substance. The differences relative to a standard substance. State the standard substance: tetramethylsaline, TMS, and what's the right formula standard substance? SiCH34. It's SiCH34, tetramethylsaline. Tricky features: methylsaline, and 3 advantages. The molecule has 12 hydrogen atoms in identical environments, and therefore the molecule tetramethylsaline produces a single absorption peak. It's inert, it's non-toxic, it's volatile. Inert, it doesn't react with the sample. Volatile is easy to remove from the sample, and it's non-toxic. What number of peaks tells you and what spectrum has? The number of peaks tells you how many different carbon environments are present in a molecule. And spectrum has 1 peak for each carbon environment in the molecule. What is responsible for the peak at 0? TMS, tetramethylsaline, added to test compound for calibration purposes. Each peak on 1H NMR spectrum is due to one or more hydrogen nuclei in a particular environment. Numbers above peaks on 1H NMR spectrum tells you the ratio of areas under the peaks, and relative area under each peak gives you the relative number of hydrogen atoms in each environment. Define N+1 rule. N+1 rule is the idea peaks always split up into number of hydrogens on neighboring carbon plus 1. So number of hydrogens on neighboring carbon plus 1. What is shown instead of peak ratios, integration trace, and what are the increase in height? Proportional to increase of height, proportional to areas under each peak. What happens if a sample has to be dissolved? If a sample has to be dissolved, the solvent is needed, and therefore not contain 1H atoms. Deuterated solvents, hydrogen atoms have been replaced by deuterium or 2H. What is deuterium? Deuterium is an isotope of hydrogen with 2 Deuterium is an isotope of hydrogen with 2 nucleons, protons, and neutrons. And another thing that can be used as solvent is CCl4. It doesn't contain any 1H atoms. 3 reasons deuterium is used in hydrogen-free solvents: even number of nucleons, no spin, therefore does not generate a magnetic field. 4 types of peak and number of hydrogens in adjacent carbon. Single type of peak, 0 number of hydrogens in adjacent carbon. Doublet, 1 number of hydrogens in adjacent carbon. Triplet, 2 number of hydrogens in adjacent carbon. Quartet, 3 number of hydrogens in adjacent carbon. Say formula of RF and define mobile phase. RF is distance traveled by spot divided by distance traveled by solvent. And mobile phase is when molecules can move, always liquid or gas. And it should also say defined stationary phase, where molecules can't move, must be a solid or liquid on a solid support.